The Philippine Sea. 2:11 a.m. Thursday. The submarine cable that runs from Guam to Japan's Chikura landing station in Chiba Prefecture is 15,646 kilometers of fiber optic cable, approximately the diameter of a garden hose, resting on the ocean floor at depths ranging from 200 meters on the continental shelf to 8,400 meters in the Mariana Trench. Through that cable passes approximately 95% of the transoceanic data traffic that makes modern military command and control possible between the U.S. Pacific Theater and the continental United States. Not satellite links, cables. Satellites carry less than 5% of transoceanic data volume. The bandwidth physics favor fiber over radio at every scale above a single voice channel. The entire architecture of U.S. military communications in the Pacific, the secure data links, the sensor feeds, the logistics networks, the financial transfer systems that fund deployed operations, runs through cables that are publicly charted, physically accessible to any vessel with the right equipment, and legally protected only by the UN Convention on the Law of the Sea's prohibition on deliberate damage to submarine infrastructure. The legal protection had existed since 1884. The 1884 Convention for the Protection of Submarine Telegraph Cables predated both world wars, the invention of fiber optics, and the concept of cyber warfare by decades. It was the legal foundation on which 1.3 million kilometers of submarine cable infrastructure had been built across every ocean. Its prohibition on cable damage was serious and binding in international law. It had also never been enforced through military means against a state actor with the naval capability to conduct covert cable interference operations at depth. The plan's cable interference capability had been developed over 11 years, beginning with the first documented deployment of the Tan Suo Hao, the research vessel Explorer, which had been observed operating in proximity to known cable routes in the South China Sea in 2013. By 2024, the plan operated 4 vessels assessed by the Office of Naval Intelligence as having cable manipulation capability, 2 research ships with remotely operated vehicle deployment capability, and 2 specialized support vessels whose equipment packages included cable cutting and splicing tools that were standard in the commercial cable maintenance industry, and that had multiple legitimate civilian applications. The dual-use nature of the equipment made interdiction legally complex. The vessels were not warships. They were not armed. Their civilian research registrations were legitimate, and they could, using their ROV deployment capability and standard industry cutting tools, sever a submarine cable at any depth within their ROV's operational envelope, approximately 4,000 meters, in under 20 minutes. The 3 cables targeted in what U.S. post-incident analysis would designate as Operation Silk Cut were the Guam-Japan cable south of the Mariana Trench's eastern wall, the faster cable linking Guam to Japan's Miura Peninsula, and the Southeast Asia-Japan 3 cable at its shallowest waypoint northeast of Guam. Not the Mariana Trench deep sections. Those were beyond the PLAN ROV capability and would require cable ships with equipment the plan did not possess. The shallower sections, at depths between 1,400 and 2,800 meters, where the cables ran along the slopes of the Philippine Sea basin. The selection logic was specific. The 3 targeted cables were not random selections from the full inventory of Pacific submarine infrastructure. They were the 3 cables whose simultaneous disruption would produce the maximum bandwidth reduction at the Guam Cable Landing Station, while leaving enough residual connectivity that the disruption could be attributed to technical failure rather than deliberate interference. A threshold the plan's planning cell had assessed at approximately 30 to 40% bandwidth reduction. Below that threshold, the disruption was a technical event. Above it, the disruption was unmistakably deliberate. The Silk-Cut operation had been designed to land precisely at 35%. The planning had been careful. 3 cables, 3 PLAN research vessels. Each vessel had been positioning over its target cable for 6 hours under the cover of oceanographic survey operations along the Philippine Sea basin margin. Legitimate research that these vessels genuinely conducted and that provided plausible explanation for their specific operating positions. The cover was deep. The documentation that would unravel it was already accumulating in the cable monitoring system before the ROVs entered the water. At 2:11 a.m., all 3 vessels deployed their ROVs simultaneously. The cable monitoring network that the U.S. operated through the cable landing stations at Guam's Tangason Beach detected anomalous signal loss on the Guam-Japan cable at 2:31 a.m., 20 minutes after the ROV deployments began. Not an immediate severing. The cable's optical amplifiers were generating signal returns that were consistent with physical disturbance rather than clean severance. The cable was being handled, bent or stressed at some point along its length. The cable monitoring system's position estimation algorithm placed the anomaly at approximately 1,680 kilometers southwest of Guam, in 2,200 meters of water. The monitoring technician on duty had been in the role for 14 months. He had processed 3 previous anomaly alerts in that time. 2 were ship anchor dragging events that had resolved without cable damage. 1 was a minor earthquake that had caused a temporary signal degradation. This pattern was different. The anomaly was stable, persistent, and precisely located. He initiated the cable disruption protocol at 2:33 a.m. The protocol's first notification went to the cable operator's maintenance center in Tokyo. Its second notification went to the U.S. Naval Forces Marianas Command at Guam. The Naval Forces Marianas duty officer received the alert at 2:33 a.m. and cross-referenced it against the vessel tracking data that the Maritime Domain Awareness Network maintained for the Philippine Sea. The cross-reference returned a match at 2:34 a.m. 3 vessels previously identified in naval intelligence assessments as PLAN cable-capable research ships, all within 2 kilometers of charted cable routes, all having been in their current positions for more than 6 hours. The match was not a coincidence. The duty officer transmitted a flash priority alert to INDOPACOM at 2:35 a.m. At 2:36 a.m., 25 minutes after the ROV deployments, the faster cable monitoring system at Mayura Peninsula reported a similar anomaly. Stable, persistent signal degradation at a waypoint consistent with a vessel position in the Philippine Sea. The Southeast Asia-Japan 3 cable followed at 2:38 a.m. All 3 cables simultaneously showing physical manipulation signatures, all 3 coinciding with PLAN vessel positions. The pattern was unmistakable within 60 seconds of the 3rd anomaly report. At 2:39 a.m., INDOPACOM's commanding admiral was on the line with the duty officer. At 2:40 a.m., the pre-authorized response protocol for submarine infrastructure interference, designation Deep Anchor, transmitted to operational commanders. Deep Anchor had been developed 18 months earlier, following a classified assessment that identified submarine cable interference as the most likely PLAN gray zone escalation option in a Taiwan contingency pre-positioning scenario. The protocol had 3 objectives. First, document the interference operations with sufficient legal and evidentiary precision to support international legal action. Second, disrupt the PLAN ROV operations without damaging the PLAN vessels. The vessels were civilian registered. The crews were non-combatants under the PLAN's own operational cover, and any kinetic action against them would produce an international incident that served no one's interest. Third, restore cable service as rapidly as possible through emergency rerouting and emergency cable repair deployment. The documentation element had begun automatically when the cable monitoring system flagged the anomalies. The Naval Forces Marianas duty officer had preserved every data point from the Maritime Domain Awareness System, showing the PLAN vessel positions, their movement history, and the precise timestamps of their positioning relative to the cable routes. A P-8A Poseidon maritime patrol aircraft from Patrol Squadron 47 at Kadena Air Base launched at 2:41 a.m., 6 minutes after the flash alert, and was over the first vessel's position at 3:04 a.m. Its sensor suite, the AN/APS-154 Advanced Airborne Sensor Radar, its acoustic sensor array, and its electro-optical camera system, began comprehensive documentation of the vessel's precise position, heading, and activity at 3:04 a.m. The imagery and radar data were transmitted in real time to INDOPACOM, to Naval Forces Marianas, and through a secure channel to the U.S. Department of Justice's Computer Crimes Unit, which had statutory authority over violations of the Submarine Cable Act, and whose participation in the documentation process was specifically designed to ensure that the evidence collected would be legally admissible in international forum proceedings. The disruption element was the most operationally complex component. Deep Anchor's mechanism for disrupting the PLAN ROV operations without kinetic action against the vessels was acoustic. The U.S. Navy's Mk-84 Airborne Acoustic Countermeasures System, a capability developed for anti-submarine operations, but with a secondary capability against remotely operated underwater vehicles that relied on acoustic positioning systems for their navigation, could generate acoustic interference patterns at frequencies that disrupted the acoustic positioning beacons that commercial ROVs used to maintain their position relative to their surface ship control. An ROV that lost acoustic positioning reference would not become uncontrollable. It had its own inertial navigation system as a backup, but it would experience degraded position accuracy that would make precise cable manipulation significantly more difficult. A second P-8A launched from Kadena at 2:43 a.m. carrying the acoustic countermeasures payload. It reached its deployment position, a calculated acoustic propagation geometry that would place maximum interference at the PLAN ROV operating depths, without producing detectable acoustic signatures at the surface that the PLAN vessel's own acoustic monitoring could identify as intentional at 3:09 a.m. The system activated at 3:10 a.m., not at full power, at a power level that the PLAN vessel's acoustic monitoring would record as ambient ocean noise within normal statistical variance. The interference was real. Its source was deniable. The PLAN ROV operators would experience positioning degradation. They would not be able to identify the cause. The Naval Special Warfare Component activated at 2:40 a.m. Two SEAL delivery vehicle teams that had been positioned at Naval Base Guam as part of the elevated readiness posture maintained for the preceding 8 days, since the PLAN research vessels had first arrived in the Philippine Sea on their ostensible oceanographic survey, had been briefed on the cable interference contingency 3 days earlier. Their mission under Deep Anchor was not to interdict the PLAN ROVs. It was to deploy emergency cable repair beacon systems at the anomaly locations. The beacons were passive acoustic transponders that the cable repair ship operators, commercial vessels contracted by the cable operators, would use to precisely locate the cable damage points for repair operations. Deploying them from SDV teams rather than surface vessels preserved the documentation timeline, while ensuring that repair operations could begin within hours of the PLAN vessels departing, rather than days. The first SDV team launched from Guam at 2:44 a.m. and reached the Guam-Japan cable anomaly location at 3:17 a.m., 33 minutes after launching. The cable at 2,200 meters depth was below the SDV's operating envelope. The beacon was deployed at 400 meters depth, directly above the cable anomaly position, its acoustic transponder signal providing a precise datum reference for the cable repair ship that was being dispatched from its standby position 180 miles north of Guam. The dispatch had occurred at 2:42 a.m., 2 minutes after Deep Anchor activated, because the cable repair ship had been placed on 24-hour standby as part of the elevated readiness posture 8 days earlier. It was already at sea. It was already underway. It would reach the anomaly position in approximately 14 hours. At 3:22 a.m., 71 minutes after the ROV deployments and 42 minutes after the first cable anomaly was detected. The PLAN vessel operating over the faster cable anomaly began retrieving its ROV. The acoustic countermeasures interference had been running for 12 minutes. The ROV's positioning accuracy had been degraded sufficiently that the cable manipulation operation had become unreliable. The post-incident analysis, drawing on the P-8A's continuous acoustic monitoring record, assessed that the PLAN ROV had succeeded in stressing and partially cutting the faster cable's outer armor layer before the positioning degradation became operationally limiting. The fiber itself had not been severed. Signal degradation was 23%, not a clean cut, not a clean escape. At 3:29 a.m., the second PLAN vessel began retrieving its ROV from the Southeast Asia-Japan 3 cable location. The third vessel, operating over the Guam-Japan cable, retrieved its ROV at 3:34 a.m. All 3 ROVs were recovered to their motherships by 3:41 a.m. All 3 vessels began moving northwest, away from the cable routes, at speeds consistent with their stated oceanographic survey mission completion, rather than flight. They were not fleeing. They were completing their cover story with professional attention to detail. The P-8A maintained surveillance of all 3 vessels throughout their departure. Every vessel movement, every course change, every speed variation was logged against the timeline of the cable anomalies. The documentation that Deep Anchor had designed to be legally precise and internationally admissible was accumulating at the rate of 24 hours of sensor data per hour of surveillance. INDOPACOM transmitted a formal notification to the PLAN's East Sea Fleet headquarters at 3:45 a.m. through the Maritime Hotline, the same channel used for the East China Sea, or C-135 incident. The notification was 3 paragraphs. The first documented the cable anomalies and their timestamps. The second documented the PLAN vessel positions relative to the cable routes, including the precise coordination between the vessel's movements and the anomaly signatures in terms that left no reasonable alternative interpretation. The third stated that the United States had initiated legal proceedings under the 1884 Submarine Cable Convention and the UN Convention on the Law of the Seas Article 113, which requires signatory states to criminalize deliberate cable damage, and requested that the PLAN provide a full account of its vessel's operations in the Philippine Sea during the relevant window. The notification was simultaneously transmitted to the UN Secretary-General's Office and to the International Cable Protection Committee. The PLAN East Sea Fleet's acknowledgement arrived at 4:17 a.m. It stated that the vessels were conducting authorized oceanographic research operations and that any suggestion of improper activity was without foundation. The acknowledgement was filed. It joined the documentation package. The legal proceedings had their first formal exchange on the record at 4:17 a.m. The cable repair assessment completed by midday the same day. The Guam-Japan cable had been partially compromised, outer armor severed, fiber intact, signal degradation 18%, repair ship dispatched. The faster cable showed armor stress but no penetration, signal nominal, inspection recommended. The Southeast Asia-Japan 3 cable showed the most significant damage. Outer armor severed, 1 of 4 fiber pairs compromised, signal loss on the affected pair, 7% total bandwidth reduction, repair ship dispatched on priority basis. Emergency rerouting through Pacific Cable Networks had restored 94% of normal bandwidth capacity by 8 a.m. through load balancing across alternate routes. Time from first cable anomaly to deep anchor activation, 7 minutes. Time from deep anchor. Activation to P-8A over first vessel, 29 minutes. Time from acoustic countermeasures activation to first ROV retrieval, 12 minutes. Time from deep anchor activation to first SDV beacon deployed, 37 minutes. Cable bandwidth restored through emergency rerouting, 94% by 8 a.m. Cables requiring physical repair, 2 of 3. Estimated repair timeline, 11 days for Guam-Japan cable, 8 days for SE Asia-Japan, 3 cable. U.S. munitions expended, 0. U.S. personnel injured, 0. PLAN vessels engaged kinetically, 0. Cable bandwidth permanently lost, 0. Emergency rerouting and repair operations restored full capacity within 11 days. The 1884 Submarine Cable Convention had never been enforced through a formal international legal proceeding against a state actor. It was about to be. The documentation package that Deep Anchor had assembled, the cable monitoring data, the maritime domain awareness vessel tracking, the P-8A sensor records, the acoustic monitoring logs, the SDV deployment records, and the hotline exchange, was 73 gigabytes of primary source material assembled in under 3 hours. The International Cable Protection Committee's legal counsel, briefed at 9 a.m., characterized it as the most comprehensive documentation of deliberate cable interference ever compiled. The legal proceeding would take years. The precedent, once established, would not. The plan's cable interference capability was real. Its operational deployment in the Philippine Sea demonstrated that the capability was mature, coordinated, and usable in a gray zone scenario below the threshold of armed conflict. The 11 years of development, the dual-use equipment cover, the civilian vessel registrations, the legitimate research mission history, the careful selection of shallower cable waypoints, all of it represented serious operational planning that should not be dismissed as simple or unsophisticated. It was neither. What the deployment had also demonstrated, in real time against an active deep anchor response, was that the capability's deniability was not infinite. The 1,680-kilometer distance from Guam, the 2,200-meter depth, the civilian vessel covers, the dual-use equipment, none of it had been sufficient to prevent detection, documentation, and disruption within 33 minutes of the first ROV deployment. The cable monitoring system's anomaly detection had produced a position estimate accurate to within 12 kilometers in under 20 minutes. The maritime domain awareness correlation had matched vessels to cable routes in 60 seconds. The acoustic countermeasures had degraded ROV positioning without producing any detectable signature at the surface. And the 73 gigabyte documentation package had been assembled from passive monitoring data alone. No active intelligence collection, no signals intelligence exploitation, no human source reporting. The gray zone had edges. Deep Anchor had found 3 of them at 2:11 a.m. on a Thursday morning in the Philippine Sea, using systems and protocols that had been built specifically because the cable threat had been assessed as real and the response needed to be ready before the first ROV entered the water.